Okay, welcome to today's class. I think we'll start by discussing what we had looked at previously. In our last lesson, we covered an introduction to JavaScript. We said JavaScript is a language, the language of the web, rather, and it's supposed to be used for so many things. Things like form validation, things like animation, fetching remote documents, updating the DOM, amongst many other things. Then we also discussed the various versions of JavaScript. That is, we looked at ECMAScript version 5, rather the ECMAScript version 1, which was done in 1995 1999. Then ECMAScript version 2 in 2009, and of course ES5 sometimes in 2015. And we also said that from 2016 onwards, we have been using ES5, ES6 with the yearly incremental. And I believe we also looked at how to add JavaScript to our documents. Either we can use an external document or we can use the script tag. Then we looked at how to output JavaScript on our pages. And we said that JavaScript can be output either via the console or document.write or even via an alert message. Then I think we also discussed the various methods within which we can define our variables. That is using var, using let, and using const. And I also believe we discussed the differences of let, const, and var. And we mentioned things like, for example, if you're using var, it is hoisted, it is not scoped. And we also mentioned its problems is that it can be redeclared, and it can also be reassigned some values. So probably those could be some advantages and disadvantages that it has. And we also discussed let and const. So I believe that's where we stopped at last time. So I want to pick it up from there and now introduce things called variables. Now, in most programming languages, we use variables to store data that we are working with. So a variable is basically a reserved memory location where we store our working value. So if you want to work with a value for one reason or another, then we will use variables for that. So what I will do here, I will just create a new a new file, and I'll call it variables. Visual programming here. I'll collapse all this. Don't need to have all of them visible. I can come here and say new files, then variables.html. So we're going to do our variables from here. So these are variables. So variables, as we had said by definition, they are placeholders for storing working values. Sorry. So definition, variables are reserved memory location for holding working values. So the values that you want to work with will be held rather in variables. Now we have variable assignment. So we have variable assignment, and by default we use the equal to sign. So use equal to sign to assign variable a value. So this is the syntax. So the syntax for assigning a variable name should look something like this. So the syntax will be variable name is equals to value. So most of them will take that form. Not all of them, but most of them, because we have other assignment operators which are going to define, which we're going to discuss in a while. So that is how you have defined variables. Now, when you're talking about variables, there are um, requirements for naming a variable. So requirements for naming variables, they could be as follows. One, variable name must start with a letter. So all variables the name of a variable must start with a letter. So, for example, if I come down here and I say const maybe 1 ABC is equals 10, this would not work out as you're going to see. Of course, I need to put here a script so that I'm inside JavaScript. Then I can type this one inside JavaScript so that the effect is actually seen. So you can see if I try to do that, then this is not going to be allowed because the variable name here is not starting with 1, it's starting with a letter of the alphabet. So it can only start with either a letter of the alphabet or an underscore. Underscore, which is this symbol over here. The dash that points down, that is called an underscore. So it can be ABC like that or underscore ABC. These two are allowed. So long as the variable starts with either a letter of the alphabet or an underscore, then that is a valid variable name. The other condition is that variable names must not contain special characters other than the underscore. What that means is that you cannot use special characters like plus, minus, multiplication, and percentage, dollar sign. So all these things are not allowed in variable names. So you can't use them on variable names simply because they mean something in JavaScript or they're used for doing some things in JavaScript. So I can say even a space. So you cannot even put a space, say AB space C. This is not allowed. So you cannot have a space inside there. But you can have an underscore that is allowed like that. You can have numbers, letters, but you cannot have special characters. Like I cannot put multiplication sign over here and put C, right? I cannot put division sign over here, and so I cannot put plus here. It does not work. So all these special characters, you can see, it tells me there's an error. All these special characters are not allowed other than an underscore, other than an underscore. Okay. Then number three, the length of the variable name should not exceed 256 characters. Okay, so when you're defining a variable name, make sure that the length is not exceeding 256 characters. So these are the rules, these are the requirements when you're naming a variable. Start with a letter of the alphabet or an underscore, cannot contain special characters other than the underscore, and the length should not also exceed 256 characters. Now, some of the best practices, they're not a requirement, but they're best practices for variable naming are as follows. One, use appropriate variable names. That is, the variable names should have a meaning, an understandable meaning, like that. Meaning, right? So if you want to define a variable, you don't say const ABC equals to 10. I can simply say maybe say tax rate is equals to 16%. Right? So that is an example of a good tax rate. But I can also come here and say something like const TR is equal to 16. Well, TR is okay, it's tax rate, but later on into the future, I might not be able to understand what exactly I was talking about when I'm looking at TR. So if I use an appropriate name, then that makes sense. So something like, for example, I can define maybe let my year of birth, or rather maybe say something like date of birth is equals to. Well, I can define date of birth without assigning a value to it. Then I can also let something like DOB. Now this makes sense because if I use DOB and date of birth, then most of them make sense. But if I simply say something like BD, then that does not make sense. BD for birthday. So this does not make a lot of sense later on in the future, but DOB and date of birth make a lot of sense. So as you're defining a variable, also use appropriate variable names. Things that if you look at them into the future, you can't be able to easily trace what you were discussing. Then number two, use camel notation. Use camel notation when defining variables with more than one word. Variables with more than a word. So, for example, if I wanted to declare date of birth, instead of doing it like that, I could simply say something like here, let date of of birth, something like that. So you can see every time I'm expecting a place, I put a capital letter. Then this is also another way, nice way of defining a variable, because you'll have the whole name, but of course without using spaces or any other special characters, but rather by just putting capital letters where you expect spaces, and then it's actually easier to read that way. So that is something else that you might want to use. Then, of course, scope your variables appropriately. That is also very important. Scope your variables appropriately. What does this mean? It means that if I'm defining a function here, a function maybe say A, then the function A is basically returning, sorry, is maybe say I have a const here, say pi is equals 3.142. Then it is returning the circumference of a circle, which is 2 times pi times maybe say a value of maybe say 12. Then of course this function is going to return for me the circumference of a circle whose diameter uh, is 12. So something of the sort. So since I'm talking about pi inside here and I'm only using pi inside this function, well, I could have gone ahead and defined pi up here. This will still be able to work because pi is a global variable at this particular point. But because I'm only using pi for purpose of this calculation, I can scope it correctly so that I don't define it globally, then I only use it in one place. So I need to define it appropriately so that I maximize its use and also control what remains of it after the calculations have been done. So that's very, very important for us to be able to understand. Scope your variables as appropriate. Now, these are just a few requirements that you're required to know when it comes to naming or using your variable. So there is what is a must. These three must be taken care of. Then there is this. They're not a must, but you can actually use them as best practices. Now that we have that introduction of what variables are and how we can define them out of the way, let's look at the different types of variables that are supported by JavaScript. Now, technically, everything in JavaScript by default is an object. Now, I know that might sound counterintuitive based on what you want to discuss, but by default, everything in JavaScript is treated as an object. Even though we know that JavaScript supports two types of variables. We have what we call primitive variables and we have what we call object variables. So primitive variables are the ones that can more or less say hold only a single value at a time. They only hold a single value and that is basically it. They cannot store more than one value. So for example, if I'm defining pi here, you can see pi is only taking 3.142 and it cannot store anything other than 3.142, so to speak. So these ones are referred to as primitive data types. And in primitive data types, we have six of them. So we're not going maybe we might not discuss all of them, but let's just discuss the ones that we commonly use so that we are now able to see how we can be able to work with those ones. So by default, everything in JavaScript is an object, but even when that is said and done, JavaScript also supports what we call primitive data type. So if you define something as a primitive data type, it will be treated as a primitive data type. If you define it as an object, which you can override it to be an object anyway, then at that point it will be treated as an object. So you can work with it as both a primitive data type and an object data type depending on the functions you want to apply to it. But I want to focus solely right now on what we call primitive data types. So let's start with primitive data types. Sorry. So primitive data types. So data type is basically is the format in which data or variable is stored. The format within which you store a variable is referred to as a data type. So the primitive data types we have, I'll start with the first one, is what we call a string. So a string is a chain of alphanumeric characters that is uh, something that contains, rather not is, but e.g., name of a person, place, etc. So anything that involves naming names of people, names of places, and those kind of things are treated as strings. So let me give you an example of a string. So in JavaScript, strings can be defined in two ways. So I can have here let first name, then I can assign a value to it. Then I can either use a single quote like that. So single quote can be used to define a string. Then I can also define and I can use double quotes. So when you're working with JavaScript, you can either use double quotes on single quotes when you are working with strings. And I can go ahead and output this value over here. So I can say console.log. We say that is one of the ways within which you can output our variables. Then I can output my first name. Then I can put my a space. Then I can output my last name. Something like that. So if I run this one and I open my console window, I'll see Richard Onyango over here. Forget about the other things that I've loaded. It's basically because there's something called um, um, uh, this screen record over here, which is injecting some things on my page because I'm using it to record the screen. But what's important is you can see it has output a name over here. So just to make it look nicer, I can come here and say my name is R. Then I put it like that. So if I was to do that and come back here, you'll be able to see it. Now it has changed. My names are that. So that tells you that it's actually possible to work with string as with single quotes or with double quotes. So when you're working with strings, then you can use either. Okay, so that is one of the data types that we have in JavaScript, strings. The other primitive data type we have in JavaScript is what we call a number. So we also have number data types. Now, so second is number data type. So numbers represent numbers, things like whole numbers. We also have decimals. So when you're dealing with whole numbers, what you need to be very, very cautious about is the precision of the number that you're working with. So precision is very, very key when it comes to working with numbers. So precision basically means how big do you want the number to be while you're working with it. So if I'm talking about somebody's age by virtue of human life, I know there's nobody on earth who can have more than 1,000 years. So if I was declaring an age here, I'll simply declare an age as an integer. Integer means it's a number that does not have decimal places. So I can have something like 12. This is actually an integer. So integer means whole number without decimals. Then we can also have let maybe say I can define weight, and I'm expecting weight to be something like 89.7 kilos. So this one can be defined now as a real number, which means if there is a whole number plus a decimal. So, and these ones have different positions. We have something called double. We also have float. So these ones, float is a very, very large number. Double is what is sufficient for most of our operation. Again, JavaScript is intelligent enough. Once you tell it something is 12 or 18.7, it will automatically determine its data type for you. So I can come here and we'll check the type of data that has been used to define those two things, that is age and weight. So I can simply check data type used for age and weight. So here I can console.log type of age. So to tell me what age is, so I can put here age variable is of type, then I'll do that. So to tell me what type of, this should be an E, what type of variable age has been used for, then I can copy and paste the same and now give type of, this one is weight, and then I'll put here weight, like that. So if I, well, I can run this thing side by side so that now you don't have to switch back and forth. So if I did that, you can see my names are Richard, so which means it's this part over here. I'll collapse this one so it's more visible. Yeah. Then variable age is of type number, so you can see all of them are numbers. Now the only difference is that one of them is a number with float, then the other one is a number which is an integer. But you can see it has given you all of, it has given us all of them as numbers. But of course, we're working with different precisions at this point. So that is the other primitive data type that we have in JavaScript. Now, um, the third data type, primitive data type we have in JavaScript is called Boolean. Boolean. Boolean basically means true or false. So I might be wanting to work with some values and I want to check if the values are, if some values are true or not. So I can simply say here, let registration complete, registration complete equals false. So you can see this one can either be only true or false. Again, if I simply copy and paste this and say registration complete, data type is type of registration complete. So you'll be able to see that down here, registration complete now gives me a type boolean because I've given it a false value. So if I give it a true value, then it's also going to give me, it's also of type boolean. So boolean returns either true or false. And we're going to be working with these data types a lot. All right. Now, the fourth type of data, primitive data that we have in JavaScript is what we refer to as undefined. So we also have undefined data types. So undefined basically means that you define the variable, but you have not assigned a value to it. So undefined means variable is declared but never assigned a value. So it will become undefined. So let me just give an example. So I can say here, maybe let my date of birth. I don't know if I use date of birth at the top there. Yeah, I use date of birth, but I can mask this. So let me say date of birth. I define it. I don't give it a value. Then I can come here, date of birth, like that. Then I can come here and simply say uh, console.log the date of birth is, then I'll give the date of birth, like that. So if I do that, you can see the date of birth here is undefined. So I have declared it, yes, but I never assigned any value to it. So by default, it will contain undefined. Okay, and sometimes these are the kind of things that we end up dealing with, so it's also important to know that kind of data type so that you can be able to check for errors when you're performing calculations or you're doing certain things with your variables. Now the fifth and last type of primitive data type we have in JavaScript is what we call null. So null is also data type. So here it means that the data type contains zilch, nothing. So the undefined is not nothing because undefined it basically means that you have not given it any value. Null means that you've given it a null value. So null value is nothing. It is not zero. It is not blank. It is not space. It is nothing. It is vacuum, so to speak. Okay. So when you want to assign null to a variable, it's also possible to assign a value some null. So I can come here and say date of birth is equals to null, right? So if I did that, you can see first of all it's undefined. But when I come down here and I show it again, now you'll see it contains null. Null means nothing. It's not undefined. Okay, undefined means a value was never assigned to it, so it's not blank. Null means that technically it is blank, not blank because blank is also a value. It is vacuum. There's nothing stored in that particular. Nothing is actually stored in that variable data type. So these are the primitive data types that we have in JavaScript, and these are what we are going to be using for purposes of the first session of our programming concepts. So I hope that is clear. Then next we can move into operators. So operators are basically the um, operations that we apply to our variable to achieve some certain functionality. So in most programming languages, you will have operators, which essentially mean that you will have your variables. Something has to be done to those variables to be able to achieve certain results. So these things that are being done to the variables to achieve certain results are what we're referring to as operators. Okay, so I think I'll mask the rest of the code here so that it does not also fill up our fill up our script window so we can be able to understand some other elements. So we have different types of operators. We have just seen one in action. So types of operators, types of operators. So when it comes to types of operators, we have what we call assignment operators. So I'll start with number one is assignment operators. So assignment operators. So these ones are used to assign values to variables. So when you want to assign values to variable, you use assignment operators. So for example, let's say we have a value of radius of a circle. So say let radius is equal to, so that is equal to sign is the assignment operator. So I can say it is maybe say 15, right? Then I can come here and say let pi is equals, well, because I don't expect pi to change, I can declare it as a const pi is equals 3.142. Then I can now declare here another radius, the circumference is equals to, now pi r squared, or is it 2 pi d? 2 times pi times radius, something like that. So this is actually how assignment operator works. This is pi, not pied. Pi, not pied. Yeah. So if you see that, then it means that I am declaring a variable called radius and I'm assigning it a value. By the way, you can declare a variable and assign it a value later on. Okay. So I can simply say here radius is equals to 15. This is perfectly allowed. So I have defined it without assigning it a value to it. Then I've given a value to it. Then here I have assigned and gave value directly. Actually, when you define a constant, you must give it a value because it does not expect that value to change later on to the future. So you can define and give a value directly, or you can define then maybe in the future assign that value. So here I can output console.log the circumference circumference of the circle is, then now I can output my circumference. something like that. So you can see here the circumference of circle is not a number. Why is it not a number? Because I think it is using radius as it's using radius as something that is not a number. So that's why I like assigning it a value like that. Then I can mask this. So you can see if I give it a number directly, it knows that it's a number data type. If I just define it and I don't give it a data type, it will assume it is an object. That's why you had that error there. Remember, I said it's very, very important for us to understand how JavaScript works. Otherwise, as you write your code, you might end up with a few errors here and there. But that does not mean that we could not assign variable in future. The only thing we need to do is to convert radius into a number. So if I wanted to use the other method that I'd used previously, like that, I would have to come here and say, convert this radius into a number. And we have various functions that convert something into a number. That is one of them. So you see, if I did that, okay, actually that one has not even persist. So I can say pass float. So change it to a float. 2 times 5 times, that's strange. Radius, that's radius, okay. Um, yeah, that should be able to work out. Well, I don't know why this is okay. Maybe let me just stick to this method first of all. Probably we'll figure that later on in the future. That for that I don't need to pass this number, but you can actually pass variables to different data types so that now you can be able to work with them as those data types. But I think let's focus on that later. So if I was to work with numbers directly, you can see it's actually able to calculate it properly. So this is an example of an assignment operator. Now we have different assignment operators, and especially when you're dealing with mathematics, and so on and so on. So we basically look at those other operators once we're done with looking at what we call arithmetic operators. So this is one of the assignment operators that we use. There are others like well, let me just discuss the arithmetic operators, then we can come back to the assignment operators because they would work hand in hand. So the second category I have, as far as operators are concerned, are arithmetic operators. So arithmetic operators are allow us to perform arithmetic operations. Allow for arithmetic operations on variables. And arithmetic operations, they are quite a number. We have plus, we have minus. I'll just put them down here. Sorry. We have plus, we have minus, we have divide by, we have multiplied by, we have modulus. We're going to discuss what modulus is. Then we also have power. Okay, so these are the kinds of operators that we have. Of course, we also have increment and decrement. So this is addition, this is subtraction, this is division, multiplication, modulus, which means remainder after dividing x by y, remainder after dividing x and y. So if you divide x by y and the number is not a full whole number, the remainder is what is given to you. This is power of y to x. We're going to see how that works out. So maybe I can just put them on their own separate lines. So we have addition, subtraction, division, multiplication, modulus, power. Then we have increment and decrement. So this means increment by 1, and the other one means decrement by 1. So these are the the arithmetic operators we have in JavaScript. Let's just see how they work out. So I will just mask these two. Then let me just define two numbers here. So let let x is equals to 10, Then let y is equals to 4 or 3. Let, not lay. Then I can come here and I can say let c is equals to, because I have to assign a value to c, so this assignment, then now the arithmetic operation x plus y. So if c is x plus y, it means that I'm going to take 10 plus 13 becomes 13, then I store that 13 in the variable called c. So if I come down here and say console.log the sum of a and x and y is, then I'll give my variable c, something of that sort. So you can see the sum of x and y is 13. So it means I've added x and y to get 13. What if we were to do something else? So I can come here and say let x, not let x, but because I've defined C, I don't need to redefine it. And by the way, if I try to redefine C again here, it's going to give me an error. So I can say, let's see here is equals to now say x minus y. That will not work out. As you can see over here, I already declared C. And if you use let, remember we said you cannot redeclare the variable, but you can reassign its value. So the declaration is what is illegal at this particular point. But if I just wanted to assign it a new value, something like that, then that is totally allowed. So I can actually reassign it a new value. The only thing I cannot do is to redeclare it if I use let. Otherwise, if I was to use var, and then I come here and say var again, then you will be able to see that that actually allows me to achieve that. So var is, you can declare a var data type, which is a very, very bad idea, and that's why we decided to use let instead. Okay, I think I explained this last time when we were discussing the three various way within which you can define um, uh, our variables. So that's why I'll stick with let for the better part of this course syllabus. So if I did that and then I would put C here, console.log, so I'll say the difference between x and y is, then sorry, then I will output my C here. So now the difference is 7, because you can see it is 10 minus 3, which is 7. So I've said C is x minus y. And I can go on and on. I can do multiplication. So I can say C is equals to x times y. Then I can output that. So I'll simply say the product. Multiplication is product. So the product of x and y is 30. So if y is 10 times 3, then I get 30. And you can go on and on. Now let's look at the modulus, which is here. So division and multiplication, same thing. They'll be able to just divide the numbers and give you the results. But let us talk about modulus. So modulus is the remainder of the whatever is remaining after I divide x by y. So if I divide x by y, you'll see it's going to be 3 remainder 1, because 3 times 3 is 9, then 9 from 10 is 1. So the remainder after dividing 10 by 3 is actually 1. That's important because sometimes I want to perform this operation and I want to check if the division had a remainder, then how do I handle the remainder at that point? So here I can simply say C is now equals to x modulus y. So it will take x divided by y, then whatever remains, it's going to give me a figure. So I can just output this, and I say the modulus of x divided by y is c. So you can see the modulus of modulus, not module, modulus like that. So the modulus of x divided by y is 1, because x is 10 and y is 3. So 10 divided by 3 is 9 remainder 1. So that remainder is what we're looking for here, which is this value over here. That's modulus. Now, if I wanted to power x and x, if I wanted x to the power of y, I'll simply say something like this. So c is equals to x to the power of y. Okay, that means x is going to the power of y. So I can put here and say again then x to the power of y is x to the power of y is c. Sorry. So you can see if I did that, it means if I take 10 power 3, it will be 10 times 10 times 10, which is 1,000. So if I take that, then you're seeing this value is actually giving me here 1,000. So x to the power of y is actually 1,000. So that's what this item does. Then, of course, we have the decrement and the increments. So for the decrements, I can simply say x minus minus. So that means I'm going to decrement x, so I can output the value of x. So the new value of x, then I'll put is, then I can put x here. So x was 10. So now I'm expecting it to be 9. So you can see now the value of x has reduced to 9, right? Then we can also do increment. We can say y plus plus. Then I can output here and say the new value of y is, then I'll put y over here. So y was initially 3. If I increment it, now you can see it is 4. So these are examples of what we are referring to as arithmetic operators. So they help us to perform some arithmetic functions, operations as far as our variables are concerned. And these are very useful because most of the programs that you're going to write are more or less going to be using some sort of arithmetic operation for purposes of achieving some specified target that we need for our application to be able to do. Now, so that is what we are referring to as arithmetic operators. Now, let's look at logical operators. So, logical operators. So again, I'll just come here and I'll put this. So logical operators are the operators that help us to check for logic. So they help us to check for logic. They're basically just three. So we have and, which is actually written with ampersand like that. So it means that you have two conditions and you want to compare if those two conditions are actually true or false. So for example, I can say, well, I think I needed to have done the comparison operators before I did the logical operators so that we are able to say it works. So, well, let's look at uh, comparison operators first, then you can look at logical operators. So, comparison operators. So, these operators are used to compare values or conditions. So they used to compare values or conditions. So there are so many, not so many, but they're quite a handful. So they are as follows. We have greater than, greater than or equal to, less than, less than or equal to, not equal to. Do we have any other? Yeah, we also have triple equal to sign, which means I'm comparing both the value and the type of data. Remember, in JavaScript, if I put 1, 2, 3, then I have 1, 2, 3, then I also put 1, 2, 3. These two things could be compared to be the same thing because if I'm looking at them from an object perspective, then they are the same thing. But of course, if I'm looking at them from a primitive data perspective, this is number and this is string. So those two things are not the same if I'm using that comparison as far as data types is concerned. But if I'm comparing them as objects, then they are actually the same thing as far as JavaScript is concerned. So if I use double triple equal to sign, it means that I want to compare the value and the data type at exactly the same time. So I compare everything, both value and data type. And that's a very important element to note because sometimes when you're working on your program and you're doing your comparison, sometimes you might end up comparing things that are not really the same. Okay, so let's dive in and let's see how this works out. So let me say I have two values. Let a is equals to say 25, and maybe say again let b is equals to 40. So I want to compare. So I can say console.log. So as we said, these comparison operators will either return true or false. They don't do anything but returning either true or false. So I can compare a is greater than b. Then I close that. So a is greater than b. Is that true? A is actually less than. This is less than. A is less than B is actually true. But if I say console.log, then A is greater than B, that should give me false because A is 25 and B is 40. So there's no way A is going to be greater than B. So that is telling me it's actually giving me false. So then I can also compare, sorry. So I can say here, let C is equals to A. Let C is equals to A. So I can come here, oh, sorry. I can come here and console.log C is equals to A. What do you expect? C is equals to A. It's true because C is equals to A, which means C is 25. So even if I put 25 here, this value will still give me true because C is 25 and A is 25. So C is equal to A. Then I can say something like console.log C is not equal to B. C is not equal to B. Of course, C is not equal to B because C is 25 and B is 40, so they're not equal. So when it comes to operators, you can be able to see that they work. So let me say D here is equals to 25. Then let me compare D and C. So if I say here console.log C is equals to D, what do you get? You can see here, I get true. Well, I cannot put values here. C is C and D is D. Then I'm also comparing C is C and D is D. So you can see, uh, well, I can just put this plus. Plus allow you to concatenate strings together. So that was actually totally not necessary. Um, well, that was totally not necessary. But if I say is C is equals to D, you can see it gives me true. But what if I add the other equal to sign? Now you can see it is false. Mm, should be false now. Or this is D. So the other one is false because as it is, this is 25 as a string, this is 25 as a number. So object wise, they are the same. Data type wise, they're not the same. This first one is a number, this other one is a string. And that's how these operators help us. So when you're working with comparison operators, less than, less than or equal to, greater than equal to, not equal to, then equal to, that is both value and type, then these are the operators that we're going to use to achieve the same operation. As I've said, they're either going to return to us true or false. Okay, so that is how these will work out. So now let's look at now the logical operators that we were discussing previously. So logical operators. So let's look at logical operators. So we said logical operators are the ones that we use to test logic. And there are only three in total. So we have and, which is written as double ampersand, like that. Then we also have or, which is written as double pipe symbol. Then we also have not, which is exclamation mark. So those are the three. Those are the only three logical operators that we can be able to use to check for logic. So let's say, for example, I want to compare if A is greater than B and if C is greater than D. So if A is greater than B and C is greater than D, then I'll return that both A and B are greater than both A and B are greater than both A and C rather are greater than B. So I'll come here and say, I'll give an example. Check if A is greater than B and if B is greater than C. Then if that is the case, then C is the largest number. So at that point, C will be largest. So if A is greater than B and B is greater than C, then it means that, well, that's not true. Because if A is greater than B, it means A is larger. Then if B is greater than C, then it means A is the largest. Yeah, so it means A is the largest because A is greater than B and B is greater than C. So if A is greater than B and B is greater than C, then it means that A is greater than all those numbers because A can only be greater if it is more than B, and at that particular time, B is also more than C. Okay, so let's try that out and see how it works. So I'll come here and say if A, sorry, if A is greater than is written like that. Then and I said it's double ampersand like that. Then I'll say B is greater than C. Then that means that, so of course we'll put a curly bracket there. And now I can put on the browser and say console.log A is the largest number. A is the largest number. So I'll not see anything here because at this particular point, A is not greater than B because B is 40 and A is 25. So if I said A was 250, then here you'll see A is the largest number because if A is 250, it means that it is greater than B. 250 is greater than 40. But also we have said B is greater than C, which means 40 is greater than 25. So at that point, we mean that A is the largest number. Now I'm just testing and here to test that I have two conditions. The first condition I'm checking is if A is greater than B, and the other condition I'm checking if B is greater than C. So that is how you do the comparison operators. So that's and. Now I can have another thing here to check if the other condition, like maybe say I'll say if A is greater than B or B is greater than C. Now this or we write it as double pipe symbol like that. So if that is the condition, then I'll come and output here console.log C, sorry, console.log here. C is the smallest number. Um, so if did that, so you can see again, I'm outputting C is the smallest number because A is greater than B. 250 is greater than 40, or 40 is greater than 25. So either way, so even if this was smaller, this other one is going to be greater. So A is not greater than B, but B is greater than C. So it is either this condition or this other condition. So if either of them returns true, then this output here is done. So that is how you use and with or. Then there's also not. So I can simply say here if maybe say A is greater than B, and maybe, well, I can put not here because not will simply check this condition. So not can check just one condition. They don't have to be two. So you can use two or one. So if A is greater than B and I want to check the opposite. So in short, I'm trying to say A is greater than B will return true, but then I want to negate that value. So make it false. So A is greater than B. If it is true, make it false. So what I can do here is I can simply say console.log um, that. So you can see it gives me false because A is greater than B. That is false. That is A is less than B. That is actually A is greater than B. Yeah? A is greater than B is actually false. Then I'm negating that value. Ideally, should have given me true. Let me see. Yeah, A is greater than B. Yeah, why is it not working out? So maybe not in bracket. Yeah, it matters how you test it because if I put not A, it means that A is going to be false. Okay, so if I put them in brackets like that, it means that it will first of all evaluate what is inside the bracket, then whatever result that is coming out, it is what is going to be negated. So that is the not logical operator. So you can use not to compare value. So that is one way. So I can say mm, if A is not greater than, is not equal to B. If A is not equal to B, console.log A is not equal to B. So you can see here, A is not equal to B because I'm saying if A is not equal to. Okay, so there is a not here, there is an equal to here, and there is a not equal to. So if I say A is not equal to B, then you can do this. So as you can see, not operator can be used in so many application areas, both comparison, logical, or even arithmetic in that particular case. So, but what's important are specifically the two, the and the or are very, very important for us to check because they will allow us to maybe test more than one condition for a single output value. So the truth table, you can draw a truth table, and based on the truth table, you can be able to output or perform arithmetic operations based on what you intend to have. So those are comparison operators. And I want to believe that now this is clear. I think we can move to another topic, which is now functions. Let's discuss functions. So, functions. Now, what are functions? Functions are blocks of code that are designed to perform a specific operation. That's the basic definition of a function. So, a code block used to perform a specific task. A code block that is used to perform a specific task. Now, functions have two properties. They can either return a value or not. So you can have a function returning a value or it just does something and does not perform a value. Alternatively, functions can either have input parameters or not. So a function can have input parameters or it might not have input parameters. It will all depend on really how you want to write it. So I'll just go ahead and mask these things off here so that we are remaining with maybe say these values. Let me just work with two of them, A and B. So let's write a function. Let's write some functions here. So I'll cut these ones and maybe bring them down here so that they are closer to what we want to do, so it's clear. So let's assume we have those two numbers, and we want to write a function that adds them together. So I'll show us how to do what we call function declaration. Of course, there are different ways that you can be able to define functions in JavaScript, but function declaration is the most common way of doing it. So function declaration. So I'll come here and say function keyword. Then I'll give my function a name, some numbers. Again, when you're defining functions, just like variables, they must start with letter of the alphabet. They cannot contain spaces or special characters, and you need to give them meaningful names. So once you define the name of the function here, then you can put a normal bracket. Then if the function has variables, you can define the variables or the input parameters inside here. Otherwise, if it doesn't have those ones, then simply put curly brackets like that. Then now, inside these curly brackets is where you're going to write what you want the function to do. In this particular case, I want it to output the value of a plus b. So I can simply say here, console.log uh, a, comma, plus, then I'll say comma, b, comma, is, then I'll give my answer. Okay? So here I can say a plus b. Now, as you can see, when I declare this function over here, then it doesn't do anything. It just sits, it doesn't do anything. So I need to invoke it. So once you write a function, you need to invoke that function so that it is executed. Invoke the function so as to execute. So I can simply say here some numbers. Then I put open and closing brackets like that. That will invoke the function. So you can see here 25 plus 40 is 65. So this is the function invocation. This is the function declaration. So you declare a function, it stays idle until you invoke it. When you invoke it, it's when it performs a specific the operation that was required to do. Look at it something like when I want to say save data, that is when something needs to be done. So I need to invoke that function so that now my browser, my application is able to execute that piece of code. So this is function declaration, and this is how you invoke the function. So as you can see, this is a very pretty basic function. It does not have any input parameters, neither does it return a value. It simply takes the value of A and B, then it sums them up together and output on the console. Not a very useful way of dealing with functions. So let's rewrite it in such a way that we can give it two numbers that it can be able to test, that it can be able to add, then it can give us back the answer after it has done the operation. So I can simply say function add two numbers, then I will give it number one and number two. Once I give it number one and number two, then I'll require it to add the two numbers, then give me the total. So I can simply say here return a number one plus number two. So here you can see what I'm saying here is a function that adds two numbers. I will give it the two numbers I want it to add, then it will add the two numbers and give me back the result of that addition. So now, how do I call this function? So invoke the second function. So to invoke the second function, I'll simply say um, console.log um, so let me assume I want to add A and B. A added to B is, then I'll put A added to B because I don't know what the values are, then is. So I'm using the variables A and B, then I'll put the value here. I'll call the function add two numbers, a and b. So here, add two numbers, I'll say a and b. So you can still see I still get 65. But this is a nice way because I'm using this as a variable. Actually, I could have just come here and say let c is equals to, then I'll give c this value. So what it will do is it will add the two numbers a and b, then store the value in c. Then now c contains that variable that I want to work with, and you can still see it still gives me the 65. So in the first operation, I was summing up two numbers a and b. In this particular case, there is no input parameter, so it means that I'm passing the values literally. Then I can invoke the function. As you can see, it doesn't have any parameters. Then I rewrite the function. Now I can take two input parameters. Then it will give me back the result after adding those two numbers. So that's why I say it can either return a value or not. This one does not return any value. This one, on the other hand, returns a value. Then it can either have inputs or not. This one does not have inputs. This one has two inputs. Then now I can say the inputs of A and B, and I can actually come here and say maybe say 12 plus B. 12 plus B is 12 plus 40. You can see now that gives me 52. Now, this one here is a little bit flexible because now I can decide what values I want to give it. So if I say 12 plus 7, it should give me 19. So you can see here it's now becoming a little bit more very flexible because now I can be able to alter the parameters. Here I cannot alter the parameters unless I change the value of A and B. So I cannot have the user define these two the values for these sum of two numbers in this point, but I can definitely determine what the user can be able to output on this particular function. So those are the two types of functions that we have: the one that takes in an input or parameters, and the ones that don't, then the ones that returns values, and the ones that don't. Now, this method of defining a function here is what we call function declaration. Now, the advantage of that is that it can be hoisted, which means that even before I define this value, I can actually call it before I define it. So, which means it goes down here. And you'll still be able to see that thing works just as much as it should work because I'm saying some numbers, it has not been defined anywhere up there. It has been defined way below. So it can actually be hoisted. That's what hoisting means. It means that you can be able to use it before you define it. I don't know if that's a good idea, but I like it that way because eventually I know that I'm going to define the function, but sometimes it's not usually a good idea to write it like that, and especially if you're going to be anticipating errors of logic in nature. So you might want to use a different thing called a function expression if you want to define a function before you use it. Now, if I do this, then you can see that I can be able to use it. Now, let me define what we call a function expression. Let me say something like I want to create a function that does greetings, and this greetings is supposed to take in your name, then it's supposed to tell you thank you. So I can declare here a constant called greetings, and this greetings is going to be a function that takes in your name. Then after it takes in your name, it can greeting, something like that. Then it can take in your name. Then after it takes in your name, I can simply say something like console.log. Let me not return a value. I'll say hello. Well, this has to be a string. Then I'll put your name here and I'll ask, how are you doing? Something like that. Now, if I did this, then I come down here. Well, let me try to call it up here. If I come up here and I say greeting like that, I say greeting like that. That won't work out. So you can see I'm trying to call greeting before it has been initialized. Now this one works because I'm using a function declaration. This one does not work because I'm using what we call function expression. So this function expression won't work. But if I took this greeting and okay, let me put my name here. Maybe say Robert Redford. So you'll still see it's not able to work, But if I was to remove this and put it below the declaration like that, then you can see now it works. Hello, Robert Redford. How are you doing? Now, depending on how you want to work with the application, if you want to use function declaration, then the function declaration has to be defined prior to using it. So it means that function declarations are not hoisted. But if I'm using, I mean, function expression are not hoisted. So function expressions are not hoisted, meaning you can't use them before you declare them. Declaration. On the other hand, if you are talking about if you're talking about function declaration, which is here, so you can use them. They are hoisted, meaning can be used before definition and initialization. Definition and initialization. So that's very, very important. As you're declaring the functions, decide if it's going to be a function expression or if it's going to be a function declaration. I like function declaration because I'm lazy and I know at some point I'll need to define it anyway. So that's the comfort that I usually take these in these function things. So important is just pick one. Are you going to use function declaration or are you going to use what we call function expression? Of course, there are other ways that you can be able to define JavaScript functions. We have you can use arrow functions, which is an ECMAScript 6 or ES6 syntax to be able to define your variable still. You can also use immediately invoked functions, which means the function is defined and it is called at the same time that it is defined. So depending on the use case of that, you can also use those two other methods to define your function. But for the scope of this particular course, I will stick to these two, which is either function declaration or function expression, whichever you're going to find very appropriate for you to use in terms of scoping and how you want to work with them as either being used before definition or can only be used exclusively after definition. Okay, so I think that should wrap up our introduction towards variables and functions. We'll catch up tomorrow where we're going to look at what we call control structures in JavaScript. So again, I didn't see any of you come for cut. So I will assume that you absconded and you are no longer interested in it. So I will give you the zeros that you want for those particular cuts. Then maybe now you should struggle with figuring out how you're going to pass the main exam. For cuts, for assignments, a majority of you have still not submitted. So I'm also assuming that you also want to score a zero on the same. So as your lecturer, I'll only give you what you want, and the rest should be something that you deal with on your own. So as far as the cut issue is concerned, that is done and dusted. I prepared them. I have them on my desk. Nobody came to do them as we had agreed. But nonetheless, that is a decision. When it comes to exams, as far as the college is concerned, these are personal decisions that are made by the students. So for that particular case, I'm done with the cuts. Let's look forward to the main exam. And I want you to pay very, very keen attention to the things that I'm teaching because all these things are covered in the exam. But of importance is not even the exam, it's for you to understand how these things work out. When you start writing your project, these are the exact same things that you're going to use to write your project. Nobody will teach you at that time how to write your project. It is going to be you deciding on how to solve solutions based on the things that I'm actually showing you over here. So it is in your best interest to make sure that you understand clearly how we are doing these kinds of things. Then you can make a decision on how you can solve your own problems using the tools that I'm explaining over here. Now that we have that out of the way, I will share this video for today. Those who would find time to look at it can look at it. Those who will find time to attend tomorrow's class, attend tomorrow's class. It's going to be from 4 p.m. to 6 p.m. And I'm insisting again, it's important for you to attend the classes so that you can be able to ask questions on the fly. Looking at just the videos might not do you any service at all, because that is the same as you'd have gone to YouTube or pick a textbook and read it on your own. It might not really give you that kind of touch that you're looking for. But if you were to come to class and you ask me a question, I'll definitely tell you why I am doing X and why Z and V don't work out and stuff like that. So while you are thinking about how to go about the class, just keep that in mind. So, with that little said, I think I'll take a break, then I'll see you again tomorrow. Thank you and have a wonderful afternoon.